So what you're looking at right now on your screen is the RapidMiner Studio client. Unlike many other vendors, you're going to typically just work with this one interface that is going to be a primary tool to work with RapidMiner. During this demonstration, we'll actually focus on three key aspects. The operators here on the left is what is used to build a workflow. Typically, you build a workflow in the center area, that is the canvas. And while you're building your workflows, you'll be typically configuring parameters here on the right. That's what I'll request you all to focus on for today. So for example, any data science activity obviously starts with gathering data. RapidMiner provides connections to different databases, different file types, and you could start building your process by dragging one of these operators in the canvas area. So for example, today I'm going to read something from a database, and then on the right I'll configure how this should behave. So I'll say let's use a predefined connection. I'll pick up a predefined connection, or I could actually go ahead and define a new one. But in this case, I'll stay with my samples database and quickly build a very simple query by clicking on this button here. And for now, I'm going to get some historic customer data, and we'll see what's in the data actually in a second here. By connecting the output of this port to the result, I've actually built the simplest possible process with RapidMiner, that is, read some data from a database and deliver that result to the result port here. To run this process, all I have to really do is click this button, and RapidMiner goes ahead, connects to the database, and gets the result so that you can now start looking at it. While you're in this data view, obviously you can see the raw data itself, but you could quickly switch over to the statistics tab, and RapidMiner gives you a quick overview of the data, things like the different data columns, the data types, are there any missing values, and then depending on the data type itself, it will give you several details like the distributions, right? The charts kind of show you how the data is spread around. For non-numeric data, it will give you the actual values and the count of those, right? So this actually helps you in understanding the data, but you could also take it one step further and click on this open chart button here, or you could click on the charts tab on the left to start visualizing the data in different graphical formats. RapidMiner provides different rich graphical capabilities so that the data scientist can stay in the same platform, and while you're trying to understand the data to build your predictive model, you don't have to leave the tool to leverage visuals and BI capabilities. So right off the bat, if I look back at my statistics, there are a couple of things I noticed. My age column, I see some problems already. My minimum age is 1 and my maximum age is 112. I don't expect any customer to have age of 1, and 112 obviously maybe too high of an age for somebody to live in this day and age. So these are the data problems that you're typically going to run into, and RapidMiner now will help you fix those problems. To do that, what I'm going to do is switch back to the design tab here, and then we'll keep on building into this process that I just created. So in my case, I want to get rid of data, or rather keep the data that belongs to the right age range. So I bring in an operator called as filter examples, drop it in the pipeline, and go ahead and configure it. So in this case, I'm going to say my age has to be greater than or equal to, let's say, 18, and I'll add another entry saying age has to be less than or equal to 16. So by doing this, I just added one more step which takes care of one of the data issues, which the age was not in the expected range. I can run this process again, and obviously I can go back and check, and it seems I have fixed one problem with the data set, which is the age range was not correct. Obviously, in a real world scenario, you might have many more data problems that need to be fixed. For example, you might have a need to get rid of duplicates. RapidMiner has an operator for that. You bring in an operator, drag it in the pipeline. Maybe there was some problem with the data and there are missing values. So now I have the ability to replace missing values based on some logic that I can configure here on the right. So the idea here is, from your raw data, you're building a pipeline that cleans up that data, that prepares your data for whatever the end goal is. The end goal could be delivering a clean data set for your dashboarding, or it could be delivering a clean data set for your predictive models. And we are not only going to help you with the data cleansing part of it, RapidMiner can also help you with the data mashup part of it. We have several operators around data blending. For example, let's say I want to read from a CSV file, and I then want to join that data with the data that's coming from the cleaner pipeline here. So all I have to do is bring in appropriate operators and configure how they behave. So in this case, I get the raw data from a database, clean it up, mash it up with some data that's coming from a CSV file, join it, and deliver it further. But that's how we'll support you in the data prep activity, and all of the things that you're seeing so far, everything is reusable. We'll not touch that topic today, but the idea is you build this workflows and pipeline that can be shared across a team and people can collaborate on and build on top of. But for now, what I'm going to do is we will have a look at the data. Our use case for today would be customer churn. So we'll quickly look at what's in the data and how we can build a very good predictive model out of this. So this is again RapidMiner process that goes ahead and gets me data for every customer, each of the customer whose ID I have. I have certain demographic information, historical data. I also know who of these who have already churned out. So to learn from that data set, basically build a model out of that data, apply this data model on some other data, and predict out of my active list of customers who is going to churn so that I could potentially take some corrective actions before the customer leaves. So let's look at how you do that in RapidMiner. For the demonstration purposes, this data is very clean. So obviously I would not do any data prep steps except the one I did around the age. And to build rest of it, I'll go back to my design tab and we'll start setting up the process. So the first thing you typically do is tell RapidMiner what is that you're trying to predict. That is using an operator called as set role. A very simple operator. You drag it in the pipeline and you tell RapidMiner you're trying to predict churn. That's your churn column, and hence the role of that column is labeled. This is basically telling RapidMiner that's your target variable. Obviously, you could go ahead and add additional rows. We don't need any of that. Actually, we do need one. So we'll say my ID column is an ID column so that it does not influence the model in incorrect way. So by doing this, I have set up a couple of representative steps. I have the data. I don't need data prep, but you could have some. And then I'm telling RapidMiner what is that I'm trying to predict. Now, just like what we've been doing for the last few minutes here, the way we do data prep, blending using drag and drop operators, in a similar fashion, RapidMiner has several hundred algorithms available for modeling in a easy drag and drop possible way. So for example, let's say I want to build a simple decision tree. All I have to do is find the right operator here and configure it on the right. At this point, RapidMiner is going to take the input data set that comes in from the previous step, and it's going to deliver your model. A couple of things I'll quickly highlight here. Every model necessarily has a lot of parameters that can influence how the model is delivering results. For example, a depth of 20 could deliver a good model, but a depth of 50 could even deliver you a better model. RapidMiner's wisdom of crowd comes in to help here. If you're not sure what should be the right value to be used, RapidMiner will recommend some values based on our user community. So customers with similar data sets, similar data problems, will look at their usage patterns and we can capture that information if they decide to opt into this program. And based on that, we can guide you to understand what are the different options or how you should configure your operators. Not only that, at the bottom, RapidMiner is also going to recommend possible next options. Right? So for example, 34% of the users actually did apply model step here, which we'll use in a bit here. But the idea here is RapidMiner is going to help you not only build the model and the process efficiently, but along the way, our wisdom of crowds is going to help you make the right choices. Having said that, in this case, I have built a very simple process, gets the data, and I have a model that has been delivered. Let's quickly run this process and see what we get out of this. At this point, RapidMiner built a very simple decision tree model for us. Obviously, decision tree is one of those models which has a very visual way of representing the model. We can see actually a tree that shows you the patterns that are found in the data. For other types of models, we'll give you relevant information like coefficients or weights or expressions that are underlying, that are lying behind the model. But in this case, I have a model that's the decision tree. And for argument's sake, let's say this is a good enough model. Now, if I want to use this model to start doing my predictions, I could bring in a data set that I want to apply the model on. So in this case, I'll use the target list data set that I have here. Just to give you a glimpse into what it is, I have the exact same set of information, except in this customer's case, I do not know if they are going to churn or not. These are my active customers, and I want to be able to predict who of these people are going to churn so that I could take a necessary corrective action on that. So to now apply this model, all I really have to do is bring in the data set, right? And then we'll use a step called as apply model. And as you're noticing, between hundreds of different operators we provide, you can easily search for those operators and find the relevant ones, and then easily do the connections here. So now I'm going to connect the model and the data set that I want to score, and the output of this is going to be my prediction. And to run this process, it is as simple as, again, hitting the play button. And this is the output that came out of that prediction. We had a missing churn column, but right now, RapidMiner adds 3 new columns to the table. One is the prediction, whether somebody is going to churn or not, and obviously the confidence of how accurate the model thinks the customer is going to churn or not. So now I could easily sort it in the decreasing order, and if somebody with the confidence of 1 obviously is highly likely to churn, and as I go down the list, you'll probably see fractions in your case, so you know those customers are probably not going to churn. But now this becomes business actionable insight. Obviously, the value of these predictions is good if it is delivered in the context of business applications. So what you could do next year is, once you have the model applied, I could easily do things like, let's filter out the top 20 customers that I care about, or rather are going to churn very likely, 1 to let's say 20. And then I'm going to write this results out to some sort of database. Or maybe in case you're integrating with Salesforce, I could also do something like Salesforce, right? So I could now deliver the predictive outcomes, the predictions that came out of this process directly into a business application of interest here. So not only you're building models very efficiently, but you're delivering the predictions into a process, into a database, or into a dashboarding tool very efficiently. We have native integrations with several of the popular BI platforms like Tableau and ClickView, but obviously we can integrate with various other BI platforms to using our standard database connections. Now, the last mile of this process is obviously you have a great model, you're delivering this, and if you want this to be running automated fashion, all you have to really do is save this process. So in this case, I could go ahead and select a central repository, and let's say call this my customer churn, right? Once I have saved this process, RapidMiner has inbuilt capabilities to start scheduling. I can easily just decide how often, how frequently this process should run, on which servers to run, and so on. So you could operationalize the whole process very efficiently. Now, we went through a whole life cycle of getting the raw data. We filtered out and we took care of some of the bad data. We built a model, and then we applied the model and delivered the results back to a business application, right? So this is the overall life cycle a data scientist would go through. And as you notice so far, it is very intuitive, a very visual workflow kind of tool to build your predictive models. And we just don't help you with the basic model. RapidMiner has a variety of techniques to build predictive models and validate them and optimize them very efficiently. So for example, when I was doing this decision tree, if I want to see how good or bad this model is, right, I could go back and add a step here where I would, let's say, use a cross-validation step. I would bring in the data. Instead of this, I can add my learner, and I'm going to capture a couple of performance metrics. So by doing this, now I could run a model that gives me an indication of how good or bad the model is. Just like I did cross-validation here, that tells me this model is going to be 76% accurate. RapidMiner supports several different validation techniques. As I mentioned before, not only will we help you to build models efficiently, but you could easily try different models and you could validate those models. But obviously, at a point, you would need to start optimizing your model. So for example, when you're doing the decision tree, there are so many different parameters that can affect how the models are delivering the results. So in this case, I was able to get 76% accuracy, but maybe by changing a few of these numbers, I could get better accuracy. So a data scientist typically has to go through trial and error methods to get that appropriate value, whereas with RapidMiner, that work is offloaded to the platform. The data scientist can use several of our optimization techniques. So I could now use one of our optimization operators bring it in the pipeline here, and I will cut my validation and put it inside by double-clicking. By doing this, what I've done is I'm telling RapidMiner I'm going to try to optimize something, and to do that, all I have to do is edit the settings. RapidMiner automatically discovers the steps you're doing. In my case, I'm doing a decision tree, and let's say I want to try different values of depth. So I move it to the right, and I say let's try between, let's say, 10 and 50 in 10 steps. So at this point, RapidMiner actually builds 11 different models for you at individual values that I've mentioned in this list here, and actually compares them against each other and delivers the best model that comes out of this particular process. So not only we are building a decision tree model very efficiently, but we're also letting RapidMiner find the optimized parameters for this particular model. And to see those values, all I have to do is connect the necessary outputs here. And when I run this process, we will get the best optimized model from that particular data set. And I could also see the value that would ideally work for us. So between the different iterations that RapidMiner tried, turns out our best value was at the depth of 46, and I went actually up to 83% accuracy just by letting RapidMiner figure it out by using the optimized grid operators. So in a similar fashion, there are several different optimization techniques that take away the hard work from the data scientists, and the platform does the work of optimizing and self-tuning your operators. Not only does this deliver the best model, but if I now put this process on a scheduled basis, every time it retrains, it is going to retrain and re-optimize the model. So tomorrow, based on your new customer patterns, we might be actually able to give you a better model at the value of 33 or 46, and that system becomes an auto-correcting system. So now that we've built this process that works very well, I could easily store this model so that my scoring systems can pick it up. All I have to really do is add a store operator and configure between our repositories where it gets saved. These are repositories that will be hosted under your user control. This will be on your premises. So you get full control over how the models are deployed and who gets to use them. And last but not the least, if there is a desire to use a model in a real-time environment, in a matter of few clicks, by literally picking up a process and hitting browse, and a couple of clicks after that, we could convert any model, any process that you build in RapidMiner into a web service that can then be integrated with real-world business applications. So if you want to predict churn and your call center guys need to know if the customer who just called in is going to churn or not, the call center web app or the call center mobile app can make a call into RapidMiner, passing in a customer ID, and ask RapidMiner model, hey, is this going to churn? Is this particular customer going to churn? RapidMiner delivers the results in real time, saying 90% sure this customer is going to churn, and maybe you could give him a 10% discount to keep him loyal. So not only you can build the processes and the models very efficiently, now you can expose those models to business applications using, again, a drag and drop interface and a couple of clicks away from integrating that with other business applications. So with that, just to summarize again, we went through a whole RapidMiner life cycle. We did a lot of data prep work. We tried different models. We validated them. In this case, we were able to get 76% accuracy initially, but then we used some optimization techniques to literally go from 76 to 83% with just a few configuration changes. And then I could operationalize the whole thing in, again, a couple of click easy ways. We were all using drag and drop operators, but RapidMiner also integrates very tightly with R and Python engines. So if you already have some custom work being done in R and Python, RapidMiner can help you leverage that work, and that R and Python script can be embedded into your workflow engines. I hope the demonstration was easy enough and you're able to understand how RapidMiner can help your data science teams as well as the business analyst teams in various phases of their data science projects. At this point, I would take a pause here and would like to see if there are any questions that I could answer.